All right. Perfect. Welcome to geometry. I know you miss me. I'm out in the rain. All right. Have fun. Miss LaScala's here. Say hi to Miss LaScala. Yeah, she's here. She said she didn't want to be on my video, so we'll have to do this without her. All right. So lesson 9.6, page 399. We're going to talk about two different sections. You're going to be learning area of a sector, and then you're going to learn arc length. So what you have to learn first and foremost, the first thing you have to learn is you need to learn the first thing you need to know is, okay, how many degrees is a circle? Let's review that very quickly. What is the answer to that? The answer is what? I'll call on you, Riley, since you're always quiet. The answer is 360. That is correct. So the circle itself all the way around is 360 degrees. So what you're going to be doing and talking about, if you have a arc length, you need what the arc is, which is how do we solve for the arc. We learned that with central angles and inscribed angles. And what did we do? We found them dividing the angle in half or just exactly the same as the angle. So that's important. So if I have a circle, make sure you can see that. Can you see that okay? Yeah, perfect. All right. And it's in the central angle, and that's 60. Let's say that arc is 60. So the arc is 60. So what percentage, what fraction of the circle is this arc? So what's that fraction and how would you solve that? Well, that fraction is going to be this. It is theta over 360. Why? Because theta is the arc, okay? So whatever that arc is, so 60 over the whole thing, which is 360. So in this case, it's a pretty simple fraction. What's the fraction? 60 over 360 is, you can reduce it and it gives you 1/6. Okay? But the whole point is that's the fraction of the circle that is quantified by that arc. So here's the question. If I'm looking for the actual length from this point to this point, I need a fraction, which is theta over 360. But here's my question, and we know this because we've studied this in past chapters, 2 chapters, as a matter of fact, last chapter and chapter 2. And what was that? It was circumference. Well, what's circumference of the entire circle? What is my equation for circumference? Pi d or pi r. Joseph, great job. Way to get that one right. Quiet down, please, so that so everybody else can hear. So circumference is 2 pi r, okay, or pi d. So let's say that I give you the radius of 5. And our fraction, which we already studied. So what's my equation for arc length? So if I'm looking for arc length, what would I find? So this distance, how would I find it? It's going to be theta over 360 2 pi r. Okay, so theta over 360, 2 pi r. So arc length is this equation. So we plug in our numbers. 60 times 2 times pi times 5 all over 360. Now I can reduce. So I'm going to be left with 5 pi over 3. Okay, do not have to work out pi. You just simply have to get it to a pi form. So arc length. When the problem says I want arc length, you use this equation right here. Okay? So the equation is arc length, it's circumference times the fraction of the circle that is involved. The fraction of the circle that is involved is theta over 360. That is always going to be the case. Now, what we're going to also learn in this chapter is one other formula. So there's 2 formulas you're going to learn. The first one is the formula for arc length, which we just did. The next one is we're going to talk about the sector, the area of the sector. So what's a sector? A sector is that section, okay? And that section is, all right, is a section of it. So what is area? First off, what is the equation for area of a circle? And so what is the equation for area of a circle? Pi r squared. Good. So we learned that last chapter. Now, so once again, now what's the fraction? What's the fraction of the circle that this is? Well, we learned that. What's the equation for the fraction? Here it is. So in order to find the area of the sector, what will we do? We'll take the fraction over 360 times pi r squared. Does that make sense? So your equation is area of a sector is theta times pi r squared over 360. So you have the area, the equation you need for area of a sector is theta pi r squared over 360. So I'm going to take a break because there's a bunch of kids that want to come into study hall. I'll save this and then I will do 3 or 4 multiple problems using this equation. But these are the 2 equations you need. Arc length, area of a sector. Pause it, make sure you get those down. Those are the 2 important key things that you'll need. And then what you'll do next is you're going to figure out how to solve them using the equations. I'll show you some problems in about 2 minutes. All right, thank you. Have a good day.